So, pag sinasabing projectile motion, yung path niya is parabolic. This is a parabolic trajectory. And then, again, same with the free fall, we neglect air resistance if we solve problems regarding this projectile motion. And for the information of everyone, projectile motion is a type of a motion undergoing two directional na space or 2D space, kasi meron na siyang component on the vertical and it also has a component on the horizontal na direction. And then for projectile, it has two governing motions. So since it travels in two directions, vertical and horizontal, so for horizontal direction, we have rectilinear motion. And for a rectilinear motion, since meron tayong dalawang types nito, which is the uniform and non-uniform, for projectile motion class, since we neglect air resistance, so let's assume that it has a constant velocity. Therefore, we have a uniform rectilinear motion for our projectile motion. And then, we have free fall. Kasi dalawa, di ba? 2D yung projectile motion natin. Therefore, it also travels on the vertical direction. And then, on its vertical direction, since this is since we neglect air resistance, so the main factor that influence our motion is gravity. Again, influenced by gravity. So for projectile motion, again class, we merge the rectilinear motion and the free fall motion. So let's go to the diagram in order to visualize the projectile motion. So for the projectile motion, we have here an object on its initial state. So this is our initial position. And then again class, it travels on a parabolic path, as you can see on this red hidden lines. So it travels in a parabola, then approaches to the final position. So ito na yung final position natin. And then again, we have our initial velocity. So as you can see on this red, black arrow, that represents our vector velocity. So v naught. And then for a projectile, since dalawa na yung dalawa na yung motion na nag-govern, so we have a component, velocity component on the x. So we have v naught along x direction. And since we have free fall motion, so we also have v naught on the y direction. And sa ating projectile, we also have here the theta. Ano ba tong theta natin? This is our throwing angle. So tinathrow siya at a certain angle. Sir, how about if our theta, sir, becomes 90 degrees? Kapag yung theta natin maging 90 degrees, therefore, magiging free fall na siya. Meaning, yung motion natin is only vertical. Wala siyang horizontal. So, therefore, maka-cancel na yung rectilinear motion. How about if our theta is 0 degrees? Meaning, wala siyang free fall. It only has rectilinear motion. So, if theta is between 0 degrees to 90 degrees, therefore it is undergoing projectile motion. And during its time of flight, take note class, we have a uniform rectilinear motion. Therefore, yung initial velocity pala natin along x, so VOX initial is just the same as VOX final. And not only that, kahit saan dito na point, kahit dito na point, kahit dito na point, kahit sa maximum height, meron pa rin tayong VOX dito, VOX at the max. Still the same value with our initial velocity. Pati din dito, as it goes downwards, hindi pa rin magbabago yung velocity natin on the x direction. So take note of that one for our velocity component along x. So ganon. natin. How about our velocity along y? Since our velocity along y is influenced by g as it travels upward, therefore, magva-vary yung value natin. And you use the kinematic equation for free fall in order to solve this one. Kasi yung velocity of y natin, let's say at this point, it will slow down. And then in this point, like, maliit na lang talaga siya hanggang sa maabot siya sa maximum point wherein our VOY here, VOY max, VOY max natin is equal to 0. Kasi diba, remember sa free fall natin, yung velocity natin sa maximum height is 0. So, pagbaba na niya ulit dito, so, meron na siyang konting velocity. But, the direction of our VOY here is negative since pababa na siya. So, this point, corresponding to this point, they have the same velocity but opposite direction. The same thing with this point. Kasi diba, they are along a horizontal path. They have the same magnitude of their velocity but opposite in direction. So, mag-increase na yung velocity ng ating component along y. Then, aabot siya sa final velocity. And take note, class, yung VOY natin sa final, so VOY final is just the negative of our VOY initial. Take note of that one. They have the same magnitude but opposite in direction. The same thing with our final velocity. Diba yung V naught natin is at this angle? Our V naught also here on the final, so erase muna natin to, is just opposite. So, gaganon lang siya. Yan yung resultant. Diba? Resultant na. So, that is the V final. Our V final is just the negative of our V initial because it goes downward compared to our initial velocity which goes upward. So, ganun lang class yung projectile natin. Then, in projectile, we call this angle, so para sa mga for important this angle pala is our yung angle of impact. So, angle of impact. And then, this angle here, so magkaiba sila. This one is the throwing angle. So, throwing angle to. Throwing angle. So, meaning, since opposite yung angle dito, if you take tangent here, kasi naka velocity vector, so yung theta pala dito is just the cotangent. Para malaman natin yung, this is phi pala. So, yung phi is just the cotangent of the throwing angle. So, ganun yan. And then, another part for our projectile motion, salis mo natin to, we also have the maximum height. So, yung maximum height natin, we'll label this as delta y max. Pag sinasabing maximum height, you can use the free fall motion wherein that is the height or the max height that will be attained by an object subject to a projectile motion. So, next, again, I already discussed this one, yung mga important parts. Here we have a review. We have the throwing angle. This one, we have our final velocity, which is opposite to our initial velocity. Then we also have an angle here. We also have an angle phi, which is the angle of impact. And then, we also have the maximum height, delta y max. Of course, if we have a maximum height on the horizontal, hindi rin papatalo sa vertical. We also have the maximum displacement, delta x. And in other words, they call this as the range of your projectile motion. So yan yung range mo. So range can be applied if the final position of your object is the same or in the same elevation to your initial position. So yun lang, ito lang mga importante na part sa ating diagram ng ating projectile motion. So you have the range, the maximum height, the throwing angle, the angle of impact, and take note din class that the initial velocity is the resultant of your velocity component along x, so VOX, and then velocity component along y, so VOY. So this is our V naught. Then you can also get the resultant of your velocity of your projectile at any point here. Just use the Pythagorean identity, wherein our resultant velocity VR is just the square root of the sum of the squares of your velocity component along x plus velocity component along y. So yun lang. Kapag may mga problems that requires you to solve for the magnitude of the velocity at a certain point along the path of a projectile motion. So gamitin mo lang yung Pythagorean identities. Then let's try to solve the useful equations that governs the motion of our projectile. So in our projectile motion, again, we have two governing motions. We have the rectilinear motion, which is our horizontal motion. So ito pala is ating rectilinear. So rectilinear. So for rectilinear motion, we have first the velocity component. Kasi as we recall, we have here our resultant vector. Let's say our object is thrown initially at a certain degree. So this is our V initial, V naught. So since at a certain degree man, so we have theta here, which is our, again, throwing angle. And then, since we're talking about the horizontal motion, therefore we are aftering to the velocity at the horizontal component. So this would be our velocity at the horizontal component. This is our VOX. So therefore, ano pala yung formula natin for the velocity component? So again, recall velocity is equals to displacement over time. So this is also equal to VOX. And then if we are going to find this in terms of the initial velocity, so this is equal to VO cosine of our throwing angle, cosine of theta. Kasi na-form siya ng triangle. So ganito lang yung ating velocity component. How about our displacement? Ano yung formula natin para sa displacement? So from the first formula here in the velocity component, we can derive our displacement formula. Kasi we know that velocity is equal to displacement all over time. So just do cross multiplication. So we have delta x is equals to v along x tayo ha, kasi horizontal motion. So VOX times t. And what is our VOX again? VOX is equal to this. Therefore, we can rewrite our displacement as VO cosine theta t. So, ganun lang. Ganito lang hahanapin yung displacement natin along the horizontal direction. And take note, yung displacement tsaka yung velocity natin sa horizontal motion does not change along the path of the projectile motion. But of course, our displacement will change kasi, di ba, nagbo-move naman siya. So, ganito lang, tandaan natin, our velocity is just equal to the initial velocity times the cosine of theta. This is our velocity component along x. So, Vx. Ganun lang. Next, how about for our vertical motion? Again, we write our velocity vector for projectile since naka-throw siya at a certain angle. So, this is our V naught. And then we're going to write the angle of theta. So theta, this is our drawing angle with respect to the horizontal axis. Then if we are going to resolve its component vector, so we have a vector component along the vertical line. So we have this one. We label this as Vy kasi alam na natin yung Vx, yung horizontal motion. So therefore, recall that our velocity along y, it's just the displacement along y. So delta y all over t. And then, yung delta y over t natin, which is just equal if we resolve this, if we are going to resolve this in terms of our initial velocity. So this is equal to Vo sine of theta. So, diba? Sine of theta. So, if we're going to look for our displacement, so you can just derive this one. But again, for free fall class, recall those kinematic equations. What is our first kinematic equation nga? This is equal to the the function of our final velocity. So we have final velocity is equal to our initial velocity along x2 ha. Initial velocity along along y. So final velocity along y minus g t. So this is our first kinematic equation. How about our second kinematic equation? So we have delta y. Recall pa to ha, sa free fall to. Kasi vertical motion, delta y is equals to v o y times the time minus 1/2 g t squared. Then recall class, we all know that voy is equals to vo sin theta. So i-plug mo vo sin theta times time minus 1/2 g t squared. So this is the first and the second kinematic equation. How about for the other kinematic equation? About the third and the fourth. So let's try to recall. Actually, this is just to recall the for the topics from the previous section. So for our fourth kinematic equation, yung third pala. So this is just the square root of our final velocity along y. So vfy squared is just equal to the squared pod ng initial velocity along y minus 2g delta y. So ito ha, nadiderive na natin to sa previous na mga topics. And recall class that voy is just vo sin theta. So therefore that is vo sin theta squared minus 2g delta y. So ganun lang. Ito lang yung third kinematic equation natin. How about for our fourth kinematic equation or yung tinatawag natin na average velocity? So this is just equal to delta y equals to 1/2 then the sum of the velocities. So the sum of the velocities lang. So we have vfy plus voy all over multiplied by time t. So therefore wala dito yung acceleration due to gravity. And again, since we all know that voy is equals to v sin theta, we can rewrite this as 1/2 times vfy plus voy is v naught sin theta. So sine of theta times our time. So ganun lang. So again, this is our fourth kinematic equation for our vertical motion or free fall. So since we already through with that one, so let's try to to derive the general formula for our projectile motion. Yung general formula pala for projectile motion, this is very useful whenever you are going to find the the position of your projectile. Let's say I have here a projectile. Say I have here an object, and then I throw it at a certain angle with an initial velocity, so v naught, at a certain angle theta. Then tinuturo ko siya hanggang dito lang. Like I just want to find kung ano yung position niya dito at this point. Kasi diba it will go further pa, but I just want here. So I'll need to find ano ba yung x dito, or delta x. Then ano din yung delta y dito, yung displacement niya along the vertical axis. And not only that, how about just aftering this? So meron ka na naman ditong delta x sub 1, and then you also have here another delta y, so let's say delta y sub 1. So diba meron kang general formula in order to solve these variables, these unknown variables. So let's try. So erase muna natin dito. So this is very useful, and I will derive you this. So derive natin ha. So from horizontal uniform motion, specifically on the first kinematic equation, I mean, ano pala, sa horizontal motion, wala tayong kinematic motion kasi, kinematic equation kasi in terms of ano lang to eh. Yung ano natin, wala pala tayong acceleration. So therefore, yung velocity natin dito is constant. So we recall that the horizontal motion, we have Vox is equal to Vo cosine of theta. And then we also know that Vox is equal to displacement delta x over time, wherein if we're going to derive the formula for our time, this is just equal to t is equals to delta x all over Vox, wherein our Vox is equals to Vo cosine of theta. So ito tandaan natin yung time natin. And then here sabi dito, from the second kinematic equation for free fall, so ano yung second kinematic equation natin sa free fall? This is delta y is equals to velocity vector along y times the time minus 1/2 g t squared. And then i-substitute natin yung t dito para ma-eliminate yung t dito, and then our equation now will be in terms of x and in terms of y. So i-combine natin to. So we have here a delta y equals to Voy t minus 1 of gt squared. So and the next we combine those equations. So again we have t is equals to Vo cosine of theta. Hindi pala siya Vo cosine of theta. This is displacement along x. So we have delta x all over Vo cosine of theta. Again, how about the other equation? We have delta y is equals to Voy, or this is Vo sine of theta, kasi this is the velocity component on the y direction, times time minus 1/2 g t squared. Again, sabi dito, combine two equations using t. So therefore, our t here will be substituted here. So let's perform that one. So we have delta y is equals to Vo sine theta multiplied by delta x all over Vo cosine of theta, then minus 1/2 g, then delta x all over Vo cosine of theta, then squared natin. So squared. So as you can see, sa VO natin, ito maka-cancel out yung VO dito. So maka-cancel out na to. Then what's left is a delta x sine theta all over cosine of theta. Minus dito, we have g delta x squared, kasi diba yung variable na nasa loob ng parenthesis is squared natin, all over 2, again yung v naught mas squared din yung initial velocity, 2 vu squared, pati din yung cosine mas squared, so cosine squared theta. And recall that the equivalent of sine theta over cosine theta is tangent of theta, so this would be a delta x tangent of theta minus g delta x squared all over 2 VO, or the initial velocity, squared cosine squared theta. Therefore, in this case, you can solve either delta y is positive or delta y is negative. So it depends. Delta y. So therefore, masasolve na natin if we are given a certain object undergoing projectile motion, throw at a certain angle. Throwing angle, we have initial velocity. And then, tinathrow mo siya. So, ganon. Then, i-find mo siya. Let's say, ano ba yung displacement niya along the x direction if our height is 5 meters. So therefore, by using the general formula for projectile motion, we can now plot our projectile in terms of x and in terms of y axis by using this formula. And as you can see, the relationship for y here and x are parabolic kasi may x squared tayo dito, di ba? X squared parabola. So therefore, it conforms our condition for projectile motion that it undergoes a parabolic path or trajectory. So we also have next. So remember this guys, delta x tan theta minus g delta x squared all over 2 times the initial velocity squared times the cosine square of theta. So what are the conditions sa general formula? So meron tayong mga conditions, class. Kasi remember, isusulat natin ulit yung general formula, which is equal to delta y. It could be either positive or negative, which is equal to delta x tangent of theta minus g delta x squared all over 2 v naught squared initial velocity times the cosine square of theta. So, nun lang. So, here, our first condition, sabi dito, delta y can be positive or negative. Of course, kasi meron kasi tayong projectile na ganito yung itsura. Let's say I have here a certain object from a certain height or from a certain cliff or a building. Then I will throw it upwards at a certain angle. So we have throwing angle and we have initial velocity. So natathrow siya. Then, so you can see, class, dun siya bumaba sa ground, yung object. Therefore, yung y natin relative to the top of a certain cliff or building is already negative. So this is negative y, delta y. So therefore, our delta y has a chance na mag-negative siya or positive. How about our delta x? Ito. This delta x. Do you think may chance na mag-negative siya? Actually, wala for this condition. Kasi, magiging negative lang siya kung yung object mo is, let's say, I will throw it in that way, and then meron siya ditong, siguro, very elastic na wall or body, then, magbabounce back siya. But it's a different thing. Kasi kapag sinasabing negative of delta x, is ito yun. Negative delta x on the other side. But, for a projectile motion, walang ganito na magbabounce back. Therefore, delta x is always positive here. Kasi, it is the distance or the displacement along the path or the direction of our motion. So, yun lang yung parang first natin na condition. Delta y, or yung displacement natin along the y direction, can be positive or negative. How about the second condition? It states here that delta y is positive if the projectile hits above point of release. So, paano yan natin ma-illustrate? So, mag-positive yung delta y kapag yung projectile natin, so let's say I have a projectile here, throw at a certain angle talaga siya. We have a throwing angle, initial velocity. Magiging positive lang tayo yung delta y mo if it hits above point of release. So, it travels in a parabolic path. Then, dito lang siya tatama. At this point. So, with respect to the ground, our delta y pala is above. Positive siya kasi it hits above point of release. Asa yung point of release natin? Ito. So, therefore, ito yung first condition na positive yung y kapag yung impact niya is above the initial point of release. How about for the last condition? So, for our last condition, sabi dito, delta y is negative if the projectile hits below point of release. So, to illustrate that, again, we have an object thrown at a certain angle, theta, with an initial velocity. Then, it undergoes parabolic path, and then it goes downward pa. So, therefore, as you can see here, our delta y now is already negative. So, negative delta y with respect to our initial position, which is above the impact position. So, I think we already know the conditions, the derivation of general formula. Then, let's proceed to the other formulas that is needed in solving projectile motion problems. Let's talk about the maximum range. So, diba, ano nga yung maximum range natin? Recall, if we have an object subject to a projectile motion, thrown at a certain angle with initial velocity, follows a parabolic path, and then if the impact has the same elevation with the point of release, therefore, we can say that their horizontal distance is our maximum distance or maximum range. So, this is labeled as range or R. So, therefore, ito yung variable that we should na ating i-undergo or we need to find for its equation. So, here, I will show you the derivation of this maximum range of our projectile motion. So, here, sabi dito, when delta y is 0, delta x is maximum. Bakit? Kasi as you can see here, so diba, delta y natin, dito meron siyang value, merong value delta y, merong value si delta y, dito merong value, hanggang sa aabot yung delta y ng 0. Kapag nag-0 na yung delta y, maximum na yung value mo ng delta x, which is equal to your range. So, from the general equation of projectile motion, we equate lang pala yung delta y to 0. So, ano ba yung ulit yung ating general equation for our projectile motion? So, ano nga yun? So, that is equal to, series muna natin, recall. I think may nagjo-join. So, wait lang ha. Si Mr. Remanes. So, class, okay pa class? Are you still following? Class, are you still following? Okay. So, recall our general formula for a projectile. We have delta y is equals to delta x tangent of theta minus g delta x squared all over 2 v initial velocity squared times the cosine squared of theta. Since sabi dito, ma-attain na natin yung maximum range kapag yung delta y natin nagiging 0. So, just substitute delta y to 0. So, here, we have 0 is equals to delta x tangent of theta minus g delta x squared all over 2 v naught squared cosine squared theta. In order to eliminate the square of our delta x, we multiply both sides by 1 over delta x. So, here we have 0 pa rin is equals to tangent na lang dito. So, tangent theta minus g delta x na lang all over 2 v naught squared cosine squared theta. Since we are only aftering with delta x, so we transpose this on the other side, and then we divide tangent theta by g all over 2 v naught squared cosine squared theta. So let's do that. So we have delta x. Kapag natatranspose na natin, we have tangent of theta all over 2 initial velocity squared. I mean, this is not 2 initial velocity. This is this is g all over 2 v naught squared cosine squared theta. So ganon, take note of this one. So i-erase muna natin para hindi siya lagi. So let's continue our derivation. So here we have, doon na tayo sa part ng delta x. So again, delta x is equals to tangent of theta all over g all over 2 v naught squared cosine squared of theta. Here we take the reciprocal of this and then multiply to tangent of theta. So magiging ganito na siya, class. And then for tangent theta then i-simplify na lang natin ito as sine over cosine. So we have sine theta over cosine of theta multiplied by 2 v naught squared cosine squared theta all over g na lang matitira sa baba. Kasi diba, na-reciprocal itong denominator na ito. Then, cosine squared theta, then may cosine theta sa ibaba. We can cancel out isang cosine theta at maiiwan lang yung 1 dito. So, therefore, we have on the numerator, we have 2 v naught squared sine theta times cosine of theta all over our g. And take note, class, in trigonometry, in your identity, you have sine 2 theta is just the same as 2 sine theta cosine of theta. So just review na lang sa trigon nyo. So therefore we can plug that one in our equation. So now we already have v naught squared sine 2 theta all over g. So therefore we can now solve our range, which is equal to the square of our initial velocity times the sine of our sine 2 theta, which is our throwing angle, all over g. So divided by g. So just take note of our formula in finding the maximum range. So next, let's jump to the maximum height. So anong meron sa maximum height? So to draw this, let's say we have projectile motion, throw at a certain throwing angle with initial velocity, goes to a parabolic path, then approaches this position. So yung maximum height natin is magbe-base tayo sa ating free fall na equation. So this would be our y max. So to derive our formula, we use the second kinematic equation for our free fall. Kasi walang kaalaman yung rectilinear motion natin dito. So free fall tayo mag-focus. So ano bang second kinematic equation ng ating free fall? So recall, this is equal to delta y is equals to VOY t minus 1/2 gt squared. And then, yung t dito is it's stated here, the time to get at the top or the maximum height. So, since meron pa tayong t dito, kailangan pa natin ng isang formula or kinematic equation. So, as stated here, use first kinematic equation. So, from the kinematic equation, we have time, or again, we have final velocity or velocity at the top, Vm, is equal to initial velocity, Voy, minus g times t. Since we don't have final velocity or the velocity at the top, so this is 0. So what's left is 0 equals Voy minus gt. Then transpose this to the other side. So we have time is equal to Voy all over g. Therefore, we can now substitute this to our second kinematic equation here. So let's do that. So erase muna natin para hindi siya mag-lag. So let's do that one, class. So here we have delta y is equals to Voy. Our time is again equal to Voy. So Voy all over g, diba? Minus 1/2 g times Voy g then squared. So as you can see, we simplify. So Voy magiging squared na to kasi Voy times Voy squared all over g minus 1/2. So 1/2 g times Voy squared all over g squared. As you can see, may g sa itaas, may g sa baba. Maka-cancel out yung isa. What's left is isang g na lang sa baba. So therefore, we have Voy squared over g minus 1/2 of Voy squared all over g. So as you can see, we have Voy squared over g minus 1/2 of it. So that the remaining would be just the 1/2. So 1/2 of Voy squared over g. And we write this, or we write the final maximum height. So this is delta y max. We write the maximum height in terms of the initial velocity, v naught. So recall that Voy is equals to Vo sine of theta. So therefore, this is Vo squared sine squared theta, kasi distribute na natin yung exponent na square dito, all over 2g. So therefore, ito lang pala yung formula natin for the maximum height. So take note with this one, class. We will, or we can use this in our problem. So for the maximum height, so tapos na tayo dito. So we now jump to the time of flight. So for our time of flight, you can use any other equations for solving the time of flight. You can use the horizontal, so horizontal motion, or yung rectilinear motion, class. So horizontal motion, wherein our Vox, or component velocity along x, is just equal to Vo cosine of theta, which is equal to displacement delta x all over time. So since time of flight tayo, therefore time to get the maximum displacement or maximum range, o yung r natin. So I put here tr. So rearranging we have TR is equal to delta X all over VO cosine of theta, or this is equal to our range R all over V naught cosine of theta. So here, from the previous section, we already know that our R, or the maximum range, so again, ito yung projectile motion natin, this would be our range, our R. So ano nga yung formula ng ating R? R is equal to V naught squared sine 2 theta all over G. So sulatan natin dito, V naught G, then cosine of theta. So kino-combine ko lang dito ha. Then we have V naught sa first and V naught at the bottom. So maka-cancel yung isa. So what's left is a single V naught. So therefore our total time of flight to attain the maximum range is V naught sine of 2 theta all over G cosine of theta. But you can eliminate cosine theta on the denominator by expanding sine 2 theta. So remember from the previous section that sine 2 theta is just equal to 2 sine theta. So 2 sine of theta cosine of theta all over ito, the denominator, G cosine of theta. So as you can see, cosine theta will be cancelled out. What's left is, so this would be our TR. TR is just 2 times the initial velocity sine of theta. So sine of theta all over our G, or our time. This would be our formula for our time of flight. So next, let's jump. Let's go to sample problems. So here we have an Alaskan rescue plane drops a package of emergency rations to stranded hikers, as shown in the figure 3.10. So I will just write an illustration lang. Then the plane is traveling horizontally at 4 meters per second at a height of 1 meter, at the height of 102 meters pala ito. At a height of 102 meters above the ground. Neglect air resistance. Then our first requirement is, where does the package strike the ground relative to point at which it was released? So again, in order to solve the problem, you need to illustrate this one first so that you can visualize this, kung ano ba nangyayari sa problem natin. So we have an illustration. So we illustrate. Okay, illustrate natin. Sabi na dito, mayroong plane. So let's say this is an airplane. An Alaskan rescue plane drops a package of emergency to stranded hikers. Then the plane is traveling horizontally at 40 meters per second. So therefore, nagta-travel na pala to siya on the x direction. So we have VOX is equals to 40 meters per second. Then, at a height of 102 meters. Therefore, we have 102 meters here na height. So, 102 meters. Relative to the ground, where the the hikers pala. So, mga stranded na hikers. So, ito yung tent nila ng mga hikers. Then, tapos may trees. Ganon. So, sabi dito, neglect air resistance. So, where does the package strike the ground relative to the point at which it was released? Kasi yung goal dito is makuha ng mga hikers, syempre, yung rasyon. Kasi meron ito emergency ration. So, therefore, hindi pwede na yung plane is dito na siya mag-drop on the vertical or dito nasa naka-align na siya sa tent ng mga hikers or the location of the hikers because since naka-travel man siya, hindi siya naka-steady, therefore it undergoes projectile trajectory. So therefore, i-estimate niya na yung pag-drop niya is ganito lang. Ganito siya, ganyan, then hanggang sa matsyempo lang talaga na ma-drop. So ganyan yung ginagamit ng mga bombers noon. So they use this principle. So ito yung application ng projectile talaga. Medyo ma-apply siya sa warfare. Sa warfare yung pag-drop ng bomb, pag-drop ng mga ganun, at sa mga emergency din ng mga bagay. So here we need to find the distance of our plane relative to our hikers. So ano ba talaga yung proper distance natin para makuha talaga yung emergency region ng ating mga hikers. So here we already given a height. So meron tayong height. Then of course, since it follows free fall, so meron tayong naka-influence tayo na G. So sulat natin required. The delta x. So delta x. So let's solve. Here, since wala tayong anong kulang dito? Wala tayong VOY. Bakit? Kasi of course, yung movement ng ating or yung velocity ng ating package is initially naka-horizontal siya, relative siya sa movement ng plane. So therefore, VOY natin is equals to 0. How about our VOX? VOX is equals to 40. Then, from our horizontal motion, we know that our velocity along x is equal to the displacement, delta x, all over time. So here, yes, pwede na tayo makasolve ng delta x. So delta x pala is just equal to velocity along x, which is already given times the time. Oh no, wala tayong time. So therefore, we need to look first for the time. So how are we going to solve for our time class? So maybe we can use the kinematic equation from the free fall. Kasi projectile to So meron tayong isang option kasi yung projectile has two governing motions, free fall and tsaka yung rectilinear. So let's use the free fall. In free fall, we all know that the our displacement, since meron tayong displacement dito, we have delta y is equal to 102. We know that delta y is equals to v naught y, initial velocity, times time minus 1/2 g t square. So wala tayong v naught y, so 0 ito. Therefore this second term or first term on the right side is 0. Therefore what's left is delta y is equals to negative 1/2 of g times t squared. So I will multiply class so I multiply both sides by 2 over g. I multiply negative to lang, negative 2 over g. So what's left on the right side is just the time na lang talaga. So we write here t squared is equals to negative 2 delta y over g. Then square root both sides so that our time would be equal to square root of negative 2 delta y all over g. Sir, negative tayo, 'di ba? Kapag mag-square root ng negative number, mag-math error kasi imaginary. But take note class, our delta y is not 102. It is negative 102 because our first reference is at the plane. Sa plane kasi tayo nag-refer. So therefore, negative siya. So don't worry, negative times negative is positive. So let's substitute. We have negative 2 times negative 102 divided by 9.81. So our time pala, by solving calculator, negative 2 times negative 102 all over 9.81. So you have a time of approximately 4.56. So put here approximately 4.56 second. So meron na tayong time. Then balik, or let's go back to the horizontal motion na equation, yung sa in terms of x. So balik tayo doon. So recall that our time there is delta x all over vox. Then our delta x, since yun yung nahanap natin, is equals to vox times our time. Then we all know time and vox is 40 meters per second, multiplied by our time, which is approximately 4.56 second. Therefore makancel yung second dito. What's left is meters, so correct tayo. Our displacement is in meters. So 40 times 4.56, we have 182.4. So right there, 182.4 meters. Therefore class, ito pala yung proper distance ng pag-drop ng emergency ration in order for the hikers to get it, para hindi siya malampas dun sa location ng ng hikers. So let's go to the second requirement, kasi that is only for letter A. So next, the next requirement is, what are the horizontal and vertical components of the velocity of the package just before it hits the ground? Again, meron tayong airplane dito. We only have vox, which equals to 40. Then dinadrop siya dun sa mga hikers. So, let's say 10 na mga hikers. Then we already know that the height is 102. And we already know that the displacement delta x from the previous na calculation is approximately 182.4. So ganon. So ang required natin is the horizontal component. So here, we let this as our final, yung position ng ating hikers. So final, ito yung initial natin na position. So initial. So here we say this is v final of y and v final of x. Yan yung hanapin natin. So let's solve. Solution. So in v final of x, diba, so what I have told you, our rectilinear motion or the motion on the horizontal is uniform. Therefore pala, ang atin palang v final velocity along x is just equal to the initial velocity along x, which is equal to 40 meters per second. Therefore, we already have now an answer for our final velocity on the horizontal component. How about for the vertical component? Sa vertical natin. So let's use the free fall motion. So we already have displacement. We also know g. Alam natin yung ano dito, yung g dito, g. So we try to look for kinematic equations that has this given. So pipiliin natin na may final siya, then may initial, then may displacement. So therefore we can choose the third kinematic equation, which is equal to the final velocity along y squared is equal to the initial velocity along y squared minus 2g delta y. And since we already know that delta y is 102, but in this problem this is negative 102 since our reference is at the plane, and then 102, or the location of the final position is negative or downwards. So the VOY, since we don't have VOY, this is 0. So therefore our VFY pala squared is equals to negative 2g delta y. Then take square root both sides. Therefore V final along y is equals to, or along the vertical component, is the square root of negative 2. Our g, this is 9.81, multiplied by our y, which is negative 102 meters. So therefore our VFY is equals to square root of 2 times 9.81 times 102. So we have a final answer approximately equal to, so this is approximately equal to 44.74 meters per second. If the question looks for the resultant vector, so just use Pythagorean ha. Like the resultant vector pala sa final is just equal to the square root of the sum of the squares of the final velocity along x plus the final velocity along y. So simple as that, class. Now for this problem pala, ito yung sagot natin sa isa, sa VFY, 44.74 meters per second. So class, do you have any questions so far? Class, wala yung question ato, class? Okay ra? Class, are you still there? Napa? Napa mo? Ano pa? Kina-catch up ra? How about the others? Okay. 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 So I think na nagkuha no. Do you have any class after 11 or 12? Na may class? What time? 11? 1:30. Okay, siguro until lang tayo. Let's just finish projectile, and so na may klase 1:30 no. Circular motion. I think circular motion medyo mabilis lang. So, okay. Let's have the problem. Again, problem 1 pa rin, but the third requirement tayo. So again, same problem, Alaskan rescuer plane, dropping a package. So the next requirement is the angle of impact. So we have phi. Diba? Remember on the when I discussed to you the parts of the projectile motion diagram. So this phi indicates our impact angle. So therefore, kung ito yung plane natin, position ng plane, it drops a certain package to this final position. Therefore, angle of impact is ito. This one, phi. So as you can see on this right triangle, we have this resultant, V final, and then here is our Vy. Diba class? Vy. And then also our Vx. Vx. Okay, Vx. Vx sa final. Vy sa final. Then this is our phi. So therefore, solution, we already know that our V final along x is equals to 40 meters per second, and our V final along y is approximately equal to 44.74. So 44.74 meters per second. So just refer to the triangle here, we can solve the impact angle tangent of theta lang. So tangent of theta, since this is a right triangle, is equal to VFY over VFX. So plug in the values. We have 44.74 all over 40. So take the arctangent. So theta equals to arctangent of, what's the answer for this? So 44.74 divided by 40. So our answer is 1.1185, approximately 1.1185. So our angle, or our impact angle pala, phi, sorry, our impact angle is equals to arctangent of this. So arctangent of 1.1185 is equals to 48.20, approximately equal to 48.20 degrees. So this would be our impact angle. But in other books, their impact angle is the opposite one, or the complementary angle of this phi. Because in other books, they say that this one here, okay, let's erase first. Iba yung impact angle nila. Yung impact angle nila is ito. Let's say I have here the final position, then our resultant velocity of our final velocity. And then we have component along y, so Vy. But it depends, magod. It depends upon how you're going to interpret this is Vx in the final position, Vy in the final position. So ito yung angle nila. Let's say this is angle gamma. Ito yung impact angle nila. So what is this gamma? Gamma is just, or tangent of that gamma is equals to iba na, hindi na siya VFY, this is VFX na, all over VYF, VFY. So ganun. Therefore, yung relationship ng ating phi dito at saka gamma is just equal to 90 degrees minus the angle of phi. So it depends. Kapag yung sagot doon is complementary angles, therefore it refers to this angle pala, this impact angle. But don't worry, both of them are impact angle, used to measure the impact angle, but it just depends upon the reference point, or the reference line. So next, how about this one? Sabi dito, a ball is thrown upward from the top of a building at an angle of 30 degrees above the horizontal and with an initial speed of 20 meters per second as in a figure 3.12. So dito, ito yung building natin. Then, of course, meron siyang, ano yung 30 degrees? This is our throwing angle. So, throwing angle to. Throwing angle. And then, the point of release is 45 meters above ground. Therefore, 45 meters is the height of your building, and the from the top of the building towards the position of the ball na naa siya sa human. Then, we have 3 questions. The first one is, how long does it take for the ball to hit the ground? Therefore, it pertains to the time from this position going to the maximum height, then going down. So, yun lang. Then, B, find the ball speed at impact. Therefore, dito siya na speed. We let this as the final speed. Kasi, ito yung impact, ha? Impact. Yan. Then, last is find the horizontal range of the ball. So, the horizontal range refers to this X here. So, again, ha? Neglect air resistance. So, let's try to solve for letter A. Sabi dito, how long does it take for the ball to hit the ground? So, our required here is T. So, t ha. In solving for t, actually, meron kang marami kang mga paraan pag-solve ng t. But, in order to make things easy, you just use this single kinematic equation that would tell directly your value of t, or t there is, or t here is or pertains the total time of flight. So let's solve. We all know that the second kinematic equation for free fall, kasi free fall tayo, kasi kung sa horizontal motion tayo, di ba? Projectile is dalawa, horizontal motion tsaka free fall motion. Kung sa horizontal kasi maraming lacking na mga givens, kasi sa horizontal we have t is equals to displacement delta x all over velocity component along x. Therefore delta x natin walang given dito, therefore wala siya. So therefore we cannot use t on the horizontal component. So let's just use the formula on the free fall. So we all know that the second kinematic equation is delta y is equals to v naught along y, initial velocity along y, times the time minus 1/2 g t squared. So class, nasunod na class? Class, are you still following? Okay ra? Okay. Sige, medyo saba diri kay na ay nag-drill. So, let's continue. We all know that VOY is equals to VO sine of our throwing angle, wherein our throwing angle is 30 degrees. So, sine 30 degrees. Okay na. And then, let's plug it to our equation. So, we have, taba dyan, VOY or V naught sine 30 degrees times t minus 1/2 g t squared. So, let's substitute. Our delta y here is 45. Since our reference point is at the top of the building, therefore mag-negative to siya. So negative 45 is equal to our v naught is 20, so 20 then sine of 30 degrees then t. So parang hindi ko lang siya nilagyan ng mga units, kasi all units for our variables or our given parameters are consistent man sila in meters, in seconds, etc. Then minus we have here 1/2. Our acceleration due to gravity is 9.81 multiplied by the square root of time, so t squared. So here we have a quadratic equation in terms of the variable t. So let's just transpose the negative 45 to the other side. So we now have a quadratic equation which is equal to negative 9.81 divided by 2 is 4.905. So this is negative 4.905 t squared plus the value of 20 sine 30 is equal to 10. So plus 10 t plus 45. So by using your calculator, we have two values for our time here. So I have here in my calculator, our A is negative 4.905, our B is 10, our C is 45. So input mo na sa calculator, we have our first value of our time is equals to approximately equal to 4.22 seconds. For the second value, t sub 2, this is t sub 1, approximately equal to negative 2.18 seconds. Therefore, choose the positive. So, Emulate na natin to. Therefore, our time of flight pala is just approximately equal to 4.22 seconds. So, yun lang. Yun lang pag-solve ng ating time of flight. Or the time it take for the ball to hit the ground. So, ito kasi from initial to the impact or pag-hit niya sa ground. Next, find the ball's speed at impact. So, ano yung speed natin dito? Therefore, it pertains our final velocity, VF. Actually, we can use other kinematic or two or more kinematic equations, but I will just use the final kinematic equation, which is in terms of the average velocity, wherein we have delta y is equals to 1/2 times the sum of the initial and final velocity, but along y. So, Vy, so Vfy dito ha. So, Vfy, V final y, then, plus initial. So, plus V naught y times the time. So, since we all know that our time from the previous section, nasolve natin. Therefore, we need to look for the VFY. But VFY, okay, lagay muna natin pala para hindi tayo malilito, required. Required is VF. Meaning, makukuha natin sa equation na to is just the one component for our final velocity, which is the component along y. So, VFY pa lang dito ha. So, let's substitute. Or, I think we can just use here para mas madali. Gamitin na lang natin yung isang kinematic equation para medyo mas madali lang ma-solve. So, we just use this, the third kinematic equation, kasi fourth yun eh. You can just use Vfy squared is equals to Voy squared minus 2g delta y. Actually, class, don't worry kasi kung yun yung gagamitin mo, yung sinusulat ko kanina, still they arrive the same answer. So in here we have no worries about our variables because delta y is given. This is equal to -45 with respect to our initial position. So let's just plug in the values. This is equal to our Voy is equal to Vo squared sine squared theta kasi component to minus 2g delta of y, then Vfy squared. Take square root for both sides. So we now have the square root of Vo squared. So V naught, so we have 20 squared, then sine of 30 squared minus 2 times 9.81 times our delta y, -45. So -45 meters. After this, perform the operation. The square root of 20 squared times sine 30, then squared, minus 2 times 9.81 times -45. So the resulting answer is approximately equal to 31.35 meters per second. That is only for the velocity on the y component. How about class for the x component? So let's go for the x component. Erase muna natin to. So for x component, so we have Vfx is just equal to, remember, uniform motion kasi yung rectilinear motion natin, Vfx is just equal to the initial velocity, Vox. Wherein our initial velocity is equals to V naught cosine of the throwing angle. So let's substitute. V naught is 20 meters per second multiplied by cosine of 30 degrees. And what is this? This is 20 times cosine of 30. This is equal to 10 squared of 3, or approximately equal to 17.32. So 17.32 meters per second. Then since our required is the final velocity, therefore we get the resultant velocity. So V final pala is equals to the square root, using Pythagorean identities for the resultant. Square root of V final along x squared plus V final along y squared. So here we substitute. Our Vx is approximately 17.32. We square it. And then our final velocity for y. So let's recall. Again, medyo na yun, na erase. So i-recall ko na lang. So that is equal to our initial velocity. We have 20 sine of theta, no? So 20 squared, then sine 30 squared minus 2 times 9.81 times delta y is negative 45. So again, ito yung ano natin. This is plus approximately equal to 31 pala yung velocity natin ng y. So 31.35 squared. So ang atin palang final velocity is, so we square root 17.32 squared plus 31.35 squared. The final answer is approximately equal to 35.82 meters per second. Therefore, this is the velocity of impact. So, my question. Do you have a question, class? May question or wala? Okay, wala. So let's jump to the last question or last requirement. Our requirement is we're going to find the horizontal range of the ball. So we neglect air resistance. So when we talk about horizontal range, this pertains to our x. So ito. So delta x, or this is our range R. So solution. So recall from our formula that our range pala R, diba? Yung formula natin sa pag-find ng maximum range. This is just equal to V naught squared. V naught squared sine 2 theta all over g. But here, since our final velocity, final position is not the same, or yung elevation niya is not the same with the initial, kasi yung range lang pala na makukuha natin dito is only this. It's only here. Ito, kasi kung ito yung gagamitin mo na formula pala, guys, for class, dapat yung final position mo should be level on your initial position, which is here. Therefore, we cannot use this formula pala in order to find the horizontal range of the ball. So hindi to, ha. Dapat, if you're going to use this, see to it that the position of your final, or the final position should be level or at the same level on your initial position. So we cannot use that one. So we use the other formulas. So ano yun na formula na yun? So we go to the formula on the horizontal motion or the rectilinear motion. We know that the velocity along x, we know that Vox is equal to the displacement all over time. Then displacement is just equal to Vox multiplied by the time, and we know that Vox is just equal to the initial velocity times the cosine of the throwing angle times the time. We already have v naught, the initial velocity. We already know the throwing angle. How about for the time? Recall from the first question, we know that time is approximately 4.22 seconds kasi yung range natin is dito. Therefore, our time here is 4.22 seconds. Therefore, we can use that one to solve the last requirement. So, t pala is 4.22. So, plug in. We have initial velocity of 20 meters per second multiplied by the cosine of 30 degrees times our time. So, our time pala is 4.22. So, therefore, our displacement or our horizontal displacement is 20 times the cosine of 30 times 4.22. That would be equal to 73.09. So delta x is approximately equal to 73.09 meters. So class, nakuha class? So I think nakuha na ninyo, no? So let's go to the third problem. So again, same pa rin yung sa first, yung about sa hiker, para ma-practice na kayo. So we have here a jet plane traveling horizontally at 102 meter per second drops a rocket from a considerable height. So here, height, the rocket immediately fires its engine accelerating at 20 meter per second square in the x direction. Then, in the x direction, while falling under the influence of gravity in the y direction. Then, when the rocket has fallen 1 kilometer, find A, its velocity in the y direction, then B, its velocity in the x direction, and C, the magnitude and direction of its velocity. Then neglect air drag, and aerodynamic lift. Kasi kapag meron kang aerodynamic lift, therefore your rocket pala is unstable yung movement niya, meron siyang resultant na velocity on the y direction. So therefore hindi siya mag-go downward but will go upward. So may aerodynamic lift. So i-neglect mo to siya. Neglect mo ng air drag, neglect mo yung aerodynamic lift. So dito pala diba, meron kang plane na merong velocity of 102 meters per second. Therefore, since nakakabit si rocket, meron ding initial velocity si rocket na Vux. Same with the plane. But, sabi kasi dito, the rocket immediately fires its engines. So, yung rocket kasi, diba, yung mga missiles natin, meron din yung built-in na mga engines para ma-track niya or para masundan talaga niya yung target niya, yung location. Therefore, may siyang engine and accelerating at 20 meter per second square in the x direction. So, therefore pala class, yung ating horizontal motion pala is not already a uniform motion. Why? Because we already have this acceleration. So, take note class ha, kasi most of our example, we neglect acceleration kasi uniform motion lang. Therefore, sabi natin, the initial velocity along x is just equal to the final velocity along x. But in this problem, since meron ka ng acceleration, therefore, the initial velocity along x is not only equal. So, it's not equal anymore to our final velocity along x since we already have an acceleration. Okay, so let's try to solve. So here, solve when the rocket has fallen 1 kilometers, find its velocity in the y direction. So, velocity natin sa y direction. So, in this case, we use the free fall kasi y direction tayo eh. So y direction. Therefore, in our example here, since we only have a horizontal velocity for our rocket, diba? Horizontal velocity. Therefore, wala tayong velocity component sa y. So, we don't have VO initial velocity along y. So, VOY is 0. So, required here. Required. Find the velocity in the y direction. So, velocity in the y direction but on the 100 km na. So, 1 km pala. 1 km na direction. Na position. Maybe it's somewhere here. So, of course, in this part, meron ka ng y dito. Meron ka ng vy. So, i-denote ko as the velocity at 1 km. Ganon. So, how are we going to find this? Now, of course, syempre, we have g here. We don't have time. We have initial velocity of y, which is 0. So, look at the, find a kinematic equation that doesn't have time. So, I think we only have the third kinematic equation, which is equal to the final velocity, or the velocity at 1 km squared, is equal to the initial velocity of y squared minus 2g delta y. And since we are only looking at the position 1 km below the initial position, therefore this is negative 1,000 meters. So, dito na class, you need to be very consistent with your units. So, take the square of both sides. Square root of both sides, we have the velocity at 1 km is equal to the square root of VOY. And what's our VOY class? We don't have, so this is 0. So we have negative 2g delta y. So plug in the values. So we have negative 2. Our g, this is 9.81. How about our y? Y is negative since this is below the initial position. So we have negative 1,000 because that is 1 km. And 1 km is equals to 1,000 meters. So let's solve. This is square root of negative 2 times 9.81 times negative 1,000. So our resulting answer is approximately equal to 140. So 140.07 meters per second. So yun lang. Ito lang yung velocity natin sa y ha, after 1 kilometer. After or the rocket has fallen 1 kilometer. So ito lang. Next. The next question is its velocity in the x direction after 1 kilometer. So x direction naman. Sa last section or kanina, it is on the y direction. How about on the x direction? So let's write here requirements. Required velocity after 1 kilometer on the x. So ano kaya? Since meron tayong acceleration, take note class, we have an acceleration on the x direction. Kasi merong engine yung rocket. We have a value of a equal to, so let's go back to our given, 20 meters per second. So dito nakasulat 20 meters per second. So we use that one to solve our problem. So we have a is equals to 20 meters per second square pala. Kasi acceleration na. So therefore, use the rectilinear motion in order to solve for the velocity at 1 kilometer na displacement. So for a 1 kilometer displacement, tingnan natin kung ano yung time nila doon. Kasi yung 1 kilometer natin na displacement, it's not on y. I mean, it's not on x, but it's on y. So therefore, in order to solve that, tingnan muna natin yung time. Kasi wala tayong ma-relate kasi wala tayong delta x dito. Okay? Para ano talaga, wala tayong delta x class. Wala din tayong time. Therefore, it would be very difficult for us if one of these two parameters is lacking. Therefore, we need to find at least one of them. So, anong pwede ma-find natin dito? Time. Kasi, di ba, the parameter time can be solved both on the horizontal motion and vertical motion. So, balik na naman tayo pala class sa horizontal motion. So, for horizontal motion, at 100 kilometers, we have this one, delta y, or we just use the first kinematic equation. We have v final, or v at 1 kilometer along y is equals to the initial velocity along y minus gt. So therefore, we can now solve for the time. Now, our time here is t, transpose lang ito, tapos transpose lang ito dito sa part. So therefore, our time here is equals to voy minus v 1 kilometer along y all over g. Diba? And take note, class, please follow the sign for your velocity. Since our velocity at 1 kilometer y is downward, so therefore negative na yan siya. So always take note, class, baka magkamali yung sagot nyo. So again, balik tayo kung anong value ng ating 1 kilometer. So ito, 140.07 meters per second. Downward siya, class, ha. So 140.07. So plug in, since we don't have velocity along y, this is 0. So we have negative times negative 140. So bakit ko nilagyan ng negative? Kasi downward. 0.07 divide by 9.81. Then solve. So we have 140.07 divided by 9.81. That is equal to approximately equal to 14.28. So this is approximately equal to 14.28 seconds. So ayun. In 14.28 seconds, nakaabot na siya sa 1 kilometer. So it is already fallen a 1 kilometer distance. Take note natin, yung time pala is 14.28. Then we can now use this time in order to solve for the velocity along the x-axis. 14.28. So we can just use the first kinematic equation for rectilinear na, class, ha. Take note, rectilinear na. So for our rectilinear, so remember, we have velocity at 1 kilometer along x is just equal to the initial velocity along x plus acceleration, kasi may acceleration tayo, times the time to take there. So therefore, this is just equal to the initial velocity, cosine of 0, 0 na. So Vox is 100 meters per second, no? Oo, 100 meters per second. So sulat natin Vox. Wait lang. So just plug in direct na lang sa values. So we have here Vox is 100 meters per second. So 100 meters per second. Plus our acceleration, this is 20 meters per second. How about our time? The time there is approximately 14.28. Then from this, solve directly. 100 plus 20 times 14.28. Therefore, our velocity on the x component is approximately equal to 385.6 meters per second. So ito na yung velocity natin on the x direction. So take note, class, ha. Time is the only parameter that we can link between two motions for the vertical and the horizontal motion. So let's jump to the final requirements for this problem. So punta tayo doon. Let's say the magnitude and direction of its velocity at that distance or at that height. So requirements, we have the resultant velocity, VR at 1 kilometer. So therefore, i-recall mo na lang yung mga components mo. So ano ba yung components mo? We have x. So in this drawing, this one, so we have velocity component along x. I just label Vx, and also velocity component along y. So we have Vy. And this is our resultant, so VR. So therefore, this would be our angle. This is angle phi. So that would be our direction. So in order to solve for VR, so VR is just equal to the square root of the sum of the squares of your Vx and your Vy. Ganun lang. Then what is the value of our Vx? So from the previous, we get a value of our Vx equal to 385, approximately 385.6 squared, plus, how about our velocity along y? So this one, 140.07. So let's plug it here. So 140.07 squared. Then solve the square root of 385 squared plus 140.07 squared. The answer is 385.86. So we have here 385.86 meters per second. And in what direction does it act or does it point? So we now use the tangent kasi this is a right triangle. So tangent na. So we have here tangent for the direction. So we have tangent of phi is equals to Vy over Vx. And what is the value of our Vy? We have 140.07. Our Vx is 385.6. So therefore, our phi is just the arctangent of this answer. So we have arctangent of 140.07 all over 385, so 385.6. So our final answer is approximately 19.96 degrees. So this is 19.96 degrees relative to the horizontal. So downwards ito na angle. Downward. Okay. So class, nagets nyo lang class? Do you have any question class for this? Hello? May question kayo?